Oi, gente, tudo bem? Hello, everybody. I will first begin in Portuguese, if Abby will excuse me, just for them to
Sure.
introduce it. Então, gente, aqui a gente está aqui com o nosso convidado, que é o Avi Loeb, ou se você preferir, Abraham, que é o nome dele. Avi é o apelido, né? Bom, eu continuo com o problema da câmera, gente, então eu vou continuar sem a minha cara. O Piero, na parte técnica, colocou a minha carinha aí. Então, a gente costuma apresentar primeiro o palestrante, mas como o Avi conhece muito melhor o que ele vai fazer e o que ele faz e toda a trajetória dele, eu vou deixar que ele mesmo se apresente para eu também, porque a questão do inglês também vai dar, eu provavelmente vou dar algumas travadas. A questão do inglês, novamente reforçando o que eu coloquei para vocês no Discord e no WhatsApp. Se a tradução simultânea não funcionar, se der problemas, não sem desespero, vocês não estão entendendo? Tranquilo. A gente vai fazer a transcrição depois que tiver já gravado, o vídeo vai ficar aqui e a gente vai fazer a transcrição. O mais importante para a gente é que se torne acessível o conteúdo. Então, se vai demandar fazer uma transcrição depois com a tradução, perfeito, sem problema, a gente faz. Então, sem pânico, podem mandar as perguntas durante, né, a live no chat do próprio YouTube, quem quiser, ou se alguém tiver com problema de mandar no chat do YouTube, pode mandar pelo WhatsApp lá no grupo. Fora isso, acho que vou fazer. Parênteses, eu vou ter que fazer a tradução da pergunta de vocês. Então, assim, se parecer meio o que ela tá perguntando, eu vou traduzir a pergunta de vocês, porque ele não vai entender, né, a pergunta sendo feita em português. Mas a ideia central ele vai apresentar algumas coisas sobre o que ele faz, qual que é a trajetória dele, e depois ele vai abrir para perguntas. Vai durar aí em torno de uma hora e pouquinho, assim, segundo o que ele mesmo colocou. Então, now let's begin it. I will first ask, Abby, you prefer me to call you Abraham or Abby?
Avi would be fine, thank you.
Okay. So I told them a little about the duration of the presentation and about the questions they can make it freely on the chat. So I will ask you to first introduce yourselves, because I thought that I would like pose a lot to really speak in English about you. So I think it's better you do it.
Thank you very much. I was born on a farm in Israel, and I was very much interested in nature. I used to collect eggs every afternoon and go to the hills of the village and read philosophy books. And I was really interested in the most important questions about our existence, philosophical questions. But I ended up in astrophysics by circumstances. I had to serve in the military, and the closest thing to philosophy that I could do was physics. And I ended up in studying astrophysics. And it turns out that it's, even though it's an arranged marriage, I ended up being married to my true love, because there are fundamental questions in astrophysics that we can address using the scientific method. And one of them is whether we are alone. We know now that many of the stars, like the sun, have a planet like the Earth, roughly at the same separation. And most of them formed billions of years before the Earth and the sun. And so an interesting question is, could it be that there was an advanced technological civilization that existed billions of years ago and sent spacecraft that we can find near Earth? That's a very interesting question, and the only way to answer it is by looking through telescopes. And turns out that the first object from outside the solar system was discovered in 2017 by a telescope in Hawaii. And I wrote a book about it called Extraterrestrial that you can see in the middle of this slide. And then I also wrote a textbook about the search for extraterrestrial life that you can see on the right side. And what you see on the left is a photograph of a picture that was hung on the walls of the Berlin Academy of Science and Humanities that was taken by a photographer from Germany that came to my home. And her name is Herlinda Quilbel. And she asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, "Are we alone?" And to answer this question, I established the Galileo project, which now includes about 100 members. And I will just say in a few words what the goal of the project is, what are we trying to accomplish. And I will skip some slides in this presentation because I want to allow you to ask me many questions. So I will just do it very quickly. In fact, as I mentioned, we know that many of the stars have planets like the Earth. And when we see an emperor or a king like the one shown here that tried to conquer the piece of land on Earth, it's not very impressive because it's just like an ant trying to hug a single grain of sand on the landscape of a huge beach. There are more Earth-like planets in the observable volume of the universe than there are grains of sand on all beaches on Earth. But I can understand where it's coming from when people think that we are at the center of the world, because my daughters, when they were very young, they thought that they're at the center of the universe, and because they were at home. And that changed when they went to the kindergarten and met other kids. And an interesting question is, are we the smartest kid in our cosmic block? And we can answer this question by finding others. And my point is that our scientists, including Albert Einstein, were not the smartest probably that ever existed since the Big Bang, 13.8 billion years ago, because there are billions of planets just within the Milky Way galaxy and 1 trillion galaxies like it in the observable volume of the universe. So let me skip some slides and mention that the first object from outside the solar system was discovered in 2017. As I mentioned, its name is Oumuamua, which means a scout in the Hawaiian language, and it looked really strange. But 4 years before that, the US government detected a meteor. That's an object that burns up in the atmosphere, and it created a fireball. And from the high speed that it had, we could tell that it came from outside the solar system. It's not bound to the sun. And moreover, from the fireball, the explosion, when it went through the atmosphere, we could tell that it's made of a material tougher than iron. And we found also a second meteor from 2017 in the same catalog. Both of them are roughly the size of a basketball. Both of them appear to be tougher than iron. So there is a possibility that they might be spacecraft, that they are not rocks. And we plan to find this out by having an expedition to Papua New Guinea to scoop the ocean floor for the fragments of these meteors. In fact, maybe I'll show you a short video about that.
My name is Avi Loeb, professor of science at Harvard University. In the coming months, I'm going to lead an expedition to Papua New Guinea to scoop the ocean floor and search for fragments of the first interstellar meteor.
Although Avi is in search of what he believes may be alien technology, proof of extraterrestrial existence has never been what's driven his life's work until now.
I'm hopeful we will find something. The question is, what is it? An unusual rock, a natural object, or artificial?
Despite being the longest serving chair of Harvard University's Department of Astronomy, it wasn't until recently that he started to investigate the possibility that there is life beyond our solar system.
I found a catalog that the government compiled of meteors that were detected by government sensors that are missile warning system. I asked my student to check if any of the meteors, the fastest moving meteors, could have arrived to Earth from outside the solar system.
There was one in particular that sparked the interest of Loeb and his students, Amir Siraj.
We decided to write a paper about this meteor, which was discovered on January 8th, 2014. Light from the explosion was seen by government sensors.
Despite the government releasing limited data, he had discovered something groundbreaking. His paper laid out what he believed to be true. But 3 years after writing his findings, a major development confirmed what he knew all along.
After a few years, the release of a letter from the US Space Command in the Department of Defense stating explicitly that this meteor at the 99.999% confidence level came from outside the solar system.
Based on the speed of the meteor and how much of the object burned upon entry, Avi determined that it must be made of a material that is tougher than iron.
And so this one was an outlier in terms of its composition. It was also an outlier in terms of its speed outside the solar system. It moved at least twice as fast as stars move relative to the sun in the vicinity of the sun.
Armed with new evidence validating his findings, Avi decided to take action and make moves to recover the object, his next hurdle. Funding through private donations, he had secured a portion of the money to take the trip.
Let's continue to look for objects like it. It was obvious to us that we need to go there and collect the fragments, because to do the same thing for an object in space would cost more than $1 billion. For a cost that is 1,000 times lower, we can go to the ocean floor and collect material from an interstellar object.
Now, Avi has the task of finding an object that most likely fractured on impact, leaving fragments possibly the size of pennies lost at the bottom of the ocean. It's a challenge that might seem insurmountable in the vast existence of the Pacific Ocean. But Avi is confident they will recover what they are in search of.
It's a fishing expedition, literally speaking, and what we can do is basically take the trajectory of this meteor and extrapolate it all the way to the ocean surface. Now, of course, when the explosion took place, there were fragments generated and they were scattered over a region. One imagines that the tiny pellets would be carried farther away from the point of impact, whereas the heavier fragments will sink down closer to the impact. Finding a big chunk can inform us much more about the structure of the original object. We're planning to board the ship and build a sled and a magnet attached to it that will scoop the ocean floor, and we will go back and forth like mowing the lawns across the region 10 kilometers in size and collect with the magnet all the fragments that are attracted to it, and then brush them off and study their composition in the laboratory. This will be the first time that humans put their hands on the material that makes an object that came from another star.
With more advanced technology in our skies than in any other point in history, new findings are becoming far more frequent and impossible to ignore. Thanks to a government report that was released last year, the possibility of extraterrestrial life and the pursuit of proof of its existence is finally losing its stigma.
The stigma has been reduced. It would be the most important scientific discovery that humanity ever made, because if you think about it, it will change our perspective about our place in the universe.
With science in his corner, this professor is not intimidated by critics.
It's not a philosophical question whether we live in an environment where objects are floating around that are representing extraterrestrial technologies. We just need to use our telescopes and find out. In fact, we're not even the first to say that. Galileo Galilei said that 4 centuries ago, and he was put in house arrest. Today, he would have been canceled on social media. Once I realized that we found an object from a technological origin that was produced elsewhere, I would not seek approval from anyone else. I don't need likes on Twitter. I just want to know what it is.
Okay, so let me just say a few more words about Oumuamua, which goes beyond this expedition that was just mentioned. Oumuamua was the size of a football field, much bigger than these meteors. It came by the sun, and it came from a very special frame of reference. It was at rest relative to the local population of stars. It didn't come from any specific star because stars are moving relative to that frame. And then it was kicked by the gravity of the sun. And as it was tumbling every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. And this meant that it has a very extreme shape, most likely flat, pancake-like, which is very strange. And then it was pushed away from the sun by some force acting on it. And it didn't show any cometary evaporation. There was no cometary tail that could push it, like the rocket effect that you see in comets. And I suggested that it's being pushed by the reflection of sunlight, simply because it's very thin, just like a sail. And the fundamental question about Oumuamua was, what was it? Was it natural or artificial in origin? And my colleagues suggested maybe it was an object of a type that we've never seen before, like a hydrogen iceberg or a nitrogen iceberg, so that we don't see the evaporation, or maybe a cloud of dust particles that is very rarefied, 100 times less dense than air. All of these suggestions are problematic because for example, a hydrogen iceberg would get evaporated very quickly along its interstellar journey. A nitrogen iceberg, it's just, we don't have enough solid nitrogen on the surfaces of planets to make a big enough population of such objects like Oumuamua, a size of a football field, so that we would see one of them. And a cloud of dust particles will get heated by hundreds of degrees when it comes close to the sun, so it would not maintain its integrity. And the fundamental question is, was it an unusual rock of a type that we've never seen before, of unusual shape and unusual composition, or was it an artificial object that came from another civilization? And when you walk on the beach, very often you see rocks or seashells that are naturally produced, but every now and then you might see a plastic bottle, and that indicates that the civilization is out there. So the fundamental question is whether Oumuamua was a plastic bottle. And it turns out that a few years later, there was another object that shared the same qualities as Oumuamua. It was pushed away from the sun by reflecting sunlight and had no cometary tail. And then the astronomers from the same place, the same telescope that discovered Oumuamua, they realized that this is an object that came from Earth. It's a rocket booster that was launched in 1966 by NASA. And it had thin walls. It was made of stainless steel. Therefore, it didn't have any cometary evaporation, and it was pushed away from the sun because it had very thin walls. And so the radiation pressure pushed it. And if you think about cave dwellers that find a cell phone, they would argue that it's a rock of a type that they've never seen before. And of course, if they decide to press a button, they would realize that it's not a rock. So I would love to press a button on an unusual object like Oumuamua, or like these meteors that came from interstellar space. We found 2 of them by now, and we plan an expedition to figure out their composition. So that's very briefly what I do in terms of looking for objects that came from outside the solar system. And I would be happy to answer any questions that you have in the remaining time. Please go ahead. Sure. Well, first, this object was not cigar-shaped. It was most likely flat, pancake-like, based on the sunlight that was reflected from it. But I'm a relatively practical person, so it's not a question of numbers. It's not a question of discussing it philosophically, sitting at your home, drinking coffee and starting to argue whether they exist or not and calculating. This is not the question. It's not a philosophical question. It's just a question of using telescopes to look up, because only over the past decade, we started to develop instruments that allow us to see objects as big as a football field within the orbit of the Earth around the sun. And only over the past decade, we could detect interstellar meteors. The US government put satellites that monitor the sky and could discover such objects. So it's only over the past decade that we were able to do that, but we need to examine all the objects that are unusual. And to do that, we need to collect data, to collect evidence, to basically put money into the search. And that includes looking for unusual objects, but also when we know of one, just study it in great detail. So for example, if we can get high resolution images of any such object, that would be of great interest, because they say a picture is worth 1,000 words. If you see a close-up photograph of an object like Oumuamua, then you don't need to argue whether it's artificial or natural, because if it looks like a hydrogen iceberg or a nitrogen iceberg, you can tell that it looks different, it looks natural. But if it looks like an artificial technological object, like, for example, a light sail or a spacecraft, then you can easily tell that. And if it's a cloud of dust particles, you will not be able to land on it. You will pass through it. So my point is that with good enough data, if we had a photo album of Oumuamua, I would not need to write my book. It would have been a good photograph is worth 66,000 words, the number of words in my book. You just look at it. So it's really simple. We should be able to collect good enough data that will tell us the nature of objects that we find near the Earth. And in terms of reflected sunlight, right now we can see only objects the size of a football field. Smaller ones do not reflect enough sunlight. But the Earth, when it moves around the sun, it acts as a fishing net. It collides with objects that happen to be there at random. And as a result, these objects, because of the friction with the air, they create a fireball that lights up with the amount of energy that is similar to an atomic explosion if you are talking about an object that is 0.5 meter in size. So we could see that, and then we can look for the fragments that were left from the explosion, like we are planning to do in Papua New Guinea, and examine their composition. And if it's natural, you would be able to say, well, it's a rock. But if it's, for example, stainless steel, a type of material that we make our spacecraft from, then we should be able to tell that from the fragments. So it boils down to getting good enough data and evidence. And I don't, the arguments about the likelihood are not really relevant. What we need is to check if there are such objects. And Fermi's paradox was based on what Fermi said 70 years ago, when he didn't actually use any telescope. He just was in Los Alamos asking this question. It's just like sitting at home and saying, I don't see my neighbors. Maybe I don't have any neighbors. Well, guess what? To see your neighbors, you have to look through your windows, and you better use a telescope to find them. And so it's really a matter of putting enough resources to the search. And many of my colleagues argue that extraordinary claims require extraordinary evidence. But my point is that extraordinary evidence requires extraordinary funding. We have to fund the search in order to get that evidence. Well, that's an interesting idea to fund the exploration of space from financial benefits that we get from space. But I think we should just use our curiosity primarily to fund the space exploration. Just to give you an example, the entire world is spending $2 trillion every year on military expenses, and nothing good comes out of military conflicts. It's just a waste of our money, a waste of our energy, a waste of our time on conflicts. And if you were to use that amount of money to, for example, explore space, you could potentially launch 20 million CubeSats every year, 20 million. So even suppose you wanted to put 1 million CubeSats. A CubeSat is the size of a Rubik's Cube spacecraft that carries some electronics, sophisticated equipment. You can put artificial intelligence in it. It's a small cube that you send into space, and you can basically send 1 million such probes to 20 stars every year, just based on the amount of money we waste on military conflicts. And that's a huge number of probes. And if we were to do that over 1 billion years, we would basically send 1 million probes to every star in the Milky Way galaxy. We know that other stars formed billions of years before the sun. So if there was another technological civilization that was peaceful, that was peace-seeking, did not spend money on military conflicts, instead was spending it on space exploration, they could have deposited about 1 million CubeSats in every habitable region around every star in the Milky Way galaxy. There are tens of billions of such stars, and everyone would have 1 million CubeSats coming from that civilization that was peaceful and space exploring. And it would take about less than 1 billion years, about 500 million years, for chemical rockets to traverse the Milky Way galaxy. So within 1 billion years, such a project basically fills all the environments around stars with 1 million probes per star, using the technologies that are already proven to work. I'm not imagining here new physics, new technologies. What we already have, just dedicating the money that we usually dedicate to military conflicts, dedicating it to space exploration. And in that case, a planet like the Earth moving around the star may every now and then collide with such a probe. And that's exactly what happened when we found the interstellar meteors. We concluded that there should be about 1 million of such objects within the orbit of the Earth around the sun, with the size of a CubeSat or a watermelon or a basketball kind of scale. So my point is, if there was such a civilization that did it more than 1 billion years ago, this could be everywhere. And this may explain the fact that the interstellar meteors that we found are tougher than iron. They are extremely unusual, and we can just find it out. And so it's all a matter of priorities. And of course, in the future, we might develop technologies that allow us to launch things that are much faster than chemical rockets. And in principle, there might be things far more advanced than we can imagine right now that come from other civilizations. Right. Yeah. So in order to have a tenured appointment at the university, you need to demonstrate your leadership in a subject that is within the mainstream of science. And I worked on that for many years. I explored the physics of black holes. I founded the Black Hole Initiative at Harvard University. I also explored the first stars and galaxies. What do we expect? When did the first light, when was that produced from stars? We know that it couldn't, stars like the sun could not have existed very early in the universe because the universe was hotter and denser than the sun in the first day after the Big Bang. And so stars like the sun actually started to form about 100 million years after the Big Bang. And that's when life could have started as well. Turns out that the temperature of the universe at that time was not very different from the surface temperature of Titan, which is a moon of Saturn, located about 10 times the Earth-Sun separation. And Titan has liquid water under the surface, and the surface is frozen, but it has oceans and seas and rivers of liquid methane. There is an atmosphere above it. And that shows that in principle, you can have life as we know it under the surface of Titan, or life as we don't know it in methane, in liquid methane on the surface. And if we ever find life on Titan, which we never visited closely, if we find life there, it would say that life could have started in the universe very early, 100 million years after the Big Bang, if objects like Titan existed back then. And they don't need to be close to a star because the entire universe has that temperature of about 94 degrees above absolute zero. That's the temperature of Titan, about 1/3 of the temperature of the Earth above absolute zero, which is close to 300 degrees Kelvin. So at any event, I worked on the first stars, on black holes, on subjects that relate to the mainstream. And now, for example, the Webb telescope is finding evidence for the first galaxies, the first stars. So it's very exciting. And we also have an image of a black hole that was obtained at the Black Hole Initiative that I was the founding director of. So it's very exciting, but this also allowed me a platform to think outside the box. And sometimes the box is not in the right place. And for example, in the context of the search for signatures of technological civilizations. And it's not a popular subject. And I hope that in the future, it will become mainstream. And so what I'm saying is, in general, you should never give up on your curiosity, on your childhood interests. Sometimes you have to postpone the pursuit of those until you have a secure position, until you have the safety that allows you to explore whatever you want. But you should never abandon that. And what I tell young people is when you go to the beach, you very often find the seashells that are young, that were just swept ashore, and they have unique colors and shapes. The old seashells rubbed against each other because of waves pulling them back and forth. And because they rubbed against each other, they lost their colors, they lost their shapes, and they end up as independent. They break up into pieces that are not very different from each other. So what I tell young people is try to maintain your unique colors, the unique interests that you start from as a kid, and never give up on those, irrespective of how many challenges you face along the way. And of course, exploring a subject that not many people consider mainstream or important, this is a challenge, and it brings some friction. There is pushback from many colleagues, but at this point, I don't care about that. I just try to focus on the substance.
Right. And still in this subject about, as you said, things like the passion, keeping up the colors, né? And about this subject, we have one question here about what should anyone who's interested, maybe someday, like researching something with you, or in your into any organizations that research these kinds of things, as we're discussing, what are your recommendations? What people should pursue as a skill, as in any skill sets, or because we know that's not only passion, you know, we need to have a drive or something like this.
Yeah. So first you have to define what interests you, and there is another element of how good are you in pursuing that. Of course, I mean, you can aspire to become an athlete, but then if you don't run fast enough, or then you would not be competitive. And the same is true for anything you choose to do. So really the key is to pursue something that you are good at and that you have a passion for, because if you're not happy with what you're doing, that's not a good situation to be in, and you will never feel that you're fulfilling yourself. Yeah. The thing that you should always think about is that at the end of your life, you want to look back and think that you actually had a fulfilling life, that you made a difference, that you know, if you didn't exist, things around you would have been different. And so in order to make a difference, you need to be good at it, and you need to have the passion for it. And that is my advice. Now, it's very often the case that people have passion for something, but then they are dissuaded. Other people tell them not to pursue it because they're not really special, they don't have the talent, or because the subject is not popular enough, or because you can't make money out of it. I don't think that one should pay too much attention to such advice, as long as you are confident that this is really exciting and that you are able to pursue it better than anyone else. And a lot of the innovation comes from young people who dared to think outside the box, because many times the box is in the wrong place.
Yeah, I agree completely, because sometimes we do. Even actually here in Brazil, we don't have that much of, how can I say this, like incentives, you know, like people here are not very actually fond of scientific subjects, and the ones that are really fond of the subject, they don't have like money. Like universities here are receiving less and less money to research and etc. So it's kind of hard, because you touch the subject in a way that we can really relate, you know?
Yeah, let me say two things about science. Why is science very special? Well, first of all, it's different from politics, because politics very often enhances the differences between people. For example, the differences between nations based on borders. But if you look at there were images just over the past week from the Orion spacecraft that took images of the Earth behind the moon. That's a spacecraft sent by NASA. And in that image of the Earth, you cannot tell where the border between Ukraine and Russia is. But if you read the news, a lot of the news is about that border. But from space, the border is not apparent. You can't see it. And it shows you how politics highlights something that, you know, from far away is completely unimportant. You know, from the point of view of the universe, it's really not very significant who occupies a piece of land near the border between Ukraine and Russia. And the fact that humans are preoccupied with such issues is a result of politics. You know, politicians very often emphasize the differences between people. And science, on the other hand, is very different. Science is about sharing knowledge, collaborating with other people, not about the differences, but about the common interests of people to figure out something. And the other very important aspect of science, aside from being collaborative and sharing, the other aspect of it is that we want to understand reality. And why is that important? Well, if you think about Galileo Galilei, he was put in house arrest because he suggested that the Earth moves around the sun. And for 1,000 years, people thought, no, the Earth is at the center of the world. And you would say, okay, that's a philosophical argument. Who cares? Let the church or the philosophers decide that everything moves around the Earth and we'll continue with our business. In fact, everyone wanted to believe that because it puts humans at the center. So it was good for the church because, politically speaking, if the church tells people you are at the center, God is looking at you, then there will be more believers. So it was good for politics of the church. And Galileo came and said, look, based on looking through my telescope, it seems like maybe the Earth is moving around the sun, not the other way around. And they put him in house arrest so that nobody would listen because of politics. But if you were to ask those philosophers to design a space mission that would reach Mars, they would never get there because they argued that Mars moves around the Earth. And if you send a spacecraft to reach Mars, you will never get there if you have the wrong idea about the motion of Mars. And so my point is, it's really important to know what the truth is about reality, because then you can adapt to it. In the case of the motion of the Earth, it's not just philosophy, it's also a question of how to launch spacecraft and reach the destinations. You need to know which object is going around which object, what are the laws of gravity, and so forth. So that's where science is really important. If we didn't know what COVID-19 is, we would never develop vaccines for it. If we never knew how gravity bends space and time, that's what Einstein's theory of gravity, then we would never have GPS systems that we use to navigate. If we didn't understand quantum mechanics, we would never have the gadgets that we use, like the cell phones, the computers. So if you're happy to use computers and cell phones and internet, and you say, I don't care about science, I just want to use these gadgets. Well, these gadgets would not exist without quantum mechanics, which was discovered just a century ago. And nobody thought by discovering quantum mechanics that it will be useful for anything. It was just trying to understand how atoms work. That's all, trying to figure it out. And then once we understood that, we could build cell phones, internet, and so forth that we are using all the time. So you cannot, on the one hand, say, oh, I really enjoy technology, that's great, but I don't care much about science. I just want to buy my gadget in a store and then do whatever I want with other people, communicating with other people. I don't care about science. Well, if science did not exist, you wouldn't have that gadget. And if science will continue to work the way it is, we might have much better gadgets, things that you cannot imagine now that would look like magic. Just think about someone that used to live in caves tens of thousands of years ago. Take such a person and bring that person to New York City. That person will be overwhelmed with awe, would look at all the lights, at all the electronics, and would say, wow, that's magic. Now, all of this came because of science. Without scientific understanding, we would still be in a very primitive state, maybe in the caves. So I'm saying science is important for two things. One, to bring people together, share the knowledge, but also to advance us in understanding the reality that we live in. And why do I say it's the reality? Because after you develop scientific ideas, we apply them and we make all kinds of useful machines. We make cell phones, we make computers, we make cars. In the future, we'll make self-driving cars, artificial intelligence. All of these developments were not possible without the scientific understanding of the reality. And it's the reality because once we understand the reality, we can use it for our purposes. So it's just like understanding that you can build tools out of reality. That was, early history of humans. We started making tools. That was simple. Now we are making much more sophisticated tools. And it's all based on scientific understanding. So science is extremely important in allowing us to advance and develop much more sophisticated tools and improve our life. In principle, science, if we understand our body well enough, we may be able to repair the human body and have live forever. Why do we die? Okay, so you can say, okay, it fills me with sorrow when a relative dies and I'm really sad about it, but I don't care much about science. Well, guess what? If science will be understanding the human body well enough, just like a computer, we will be able to repair it. We will be able to update anything that is not functioning in it. And then people will live for much longer time. Maybe will live forever. So if you care about people dying, then you definitely care about understanding the human body, how it works, and how can we make humans live forever.
Yeah, I see. And as you were saying about the importance of sharing knowledge and the importance of science itself, we got actually two questions here that I'm going to link them together. And we have here one question about books. Actually, those two questions are about books. The first one is asking basically if you can give us some spoilers if you are writing something, another book or something like this, and linking this question about a book that you might be writing, if there are any books that you recommend for us for someone who wants to study techno-signatures. So
yeah, so I wrote a book last year, 2021, and it's available. It's called Life in the Cosmos, and it talks about primitive life, like microbes, but it also has about half of it is talking about techno-signatures. So if you really wanted to get into the details of what we know about the techno-signatures, what can we look for, and you want to really study that in great detail, I would recommend my textbook, Life in the Cosmos. It's in English. My book, Extraterrestrial, also talks about that, but it's at a popular level, and it was translated to Spanish, actually 3 different translations. I'm not sure which one is available in Brazil right now, but it was translated to 25 languages, and I'm sure you can find it or order it. And it gives you an overview on Oumuamua, and also more generally what kind of techno-signatures we might be looking for. And I will have a new book that is coming out at the end of August 2023 called Interstellar, and that will also discuss techno-signatures. So wait for next summer, and summer 2023 here in the United States, and in August 2023, you will be able to read some more about techno-signatures in my new book, Interstellar. It will also be translated to about 25 languages.
Oh, and about this this subject is still about techno-signatures. Do you think that's going to be an actually big area of study in the future? Actually, it already is, the studies, but how can you compare the studies and search for techno-signatures compared to biosignatures?
It's interesting because most of my colleagues, most astronomers, think that searching for biosignatures makes much more sense. So that they're asking for billions of dollars to fund future missions that would look for signs of primitive life, because they say it's much more likely to have primitive life. It started early on the Earth, and intelligent life maybe doesn't exist. We don't know. So therefore, let's search for microbes from primitive life. And one way to do that is to look for the oxygen and methane in the atmospheres of planets, because on Earth, oxygen is produced by living organisms. And the problem is that in the first half of the life of the Earth, in the first 2 billion years, there was not much oxygen in the atmosphere. And suddenly 2.5 billion years ago, the oxygen level rose in the atmosphere. But that's, if you don't find oxygen in the atmosphere of a planet, it doesn't say that there is no life there, because Earth had microbes, but the oxygen level was low in the atmosphere to start with, and for the first half of the life of the Earth. Then if you do find oxygen, maybe it's produced by natural processes. That's also possible. So it will not be conclusive. Even if we invest billions of dollars to look for oxygen in the atmospheres of other planets, it will be difficult to conclude without any uncertainty that life exists on that planet. And the idea is to find oxygen in the atmosphere when a planet passes in front of the star, so that some of the light from the star is going through the atmosphere and you can analyze it. And so what I'm saying is that if we detect, for example, industrial pollution in the atmosphere, then we know that there is not only life, but there is industrial life. And of course, to find industrial pollution requires the same kind of an experiment. You just look for the molecules that nature doesn't make without industries. There are such molecules in the atmosphere of the Earth from all the industries that are operating here on Earth. And also you can look for city lights on the night side. So night side of a planet is usually dark, but if there are city lights, you might be able to see some light coming from it. So this is an example of another technosignature. And my point, or if you find a spacecraft like I'm searching for, that's another signature of technological life. And my point is, if you find any of these, it will be unambiguous. It will be obvious that there is life. It will not be uncertain, like finding oxygen in the atmosphere of a planet. The interpretation will be quite clear. So I think that we need to invest significant funds also in the search for intelligent life, not just primitive life, but that's not a popular view within the mainstream of astronomy right now.
And still about the subject, I do have to ask you this. As you were saying, we need to fund more, but it's not popular in the scientific field to look for technosignatures. But like biosignatures, they usually come as microbes, like really small pieces of life. But isn't it easier to look for technosignatures? Because I'm going to use a sci-fi example here. Like Dyson spheres are much larger structures, mega structures of engineering, and it's only possible to find a Dyson sphere close to some technological civilization or something like this. So biosignatures usually goes in a way that we can find only small pieces of life, and technosignatures usually are like more present. Even if they are harder to find, because probably not in the Milky Way we have like another, probably speaking, statistically speaking, we might have another civilization, intelligent civilization, but I think you see where I'm going. Like, it's easier to find technosignatures because they would link directly to intelligent life. But biosignatures, 99.99 and infinite 9% is going to be about microbiology, right?
Right. I mean, the other thing to keep in mind is that if we find a more advanced civilization, we can learn from them. We can learn about new technologies that represent our future. So it offers opportunities that you don't get with microbes. And the other thing that is important to keep in mind is, in the past 70 years, we've been looking for radio signals, and they move at the speed of light. So if there was a civilization 1 billion years ago that sent radio signals and is now dead, those radio signals are now 1 billion light years away. We would never be able to detect them. But there is a different method, and that is to look for objects like I was describing, and those are moving very slowly relative to the escape speed from the Milky Way galaxy. So all the spacecraft that were launched are still around. They're bound by gravity to the Milky Way galaxy. So it's a different method. Instead of looking for radio signals, which is equivalent to waiting for a phone call at home, there is another approach, which is to go and check your mailbox for any packages that arrived in the mail. And it's possible that the senders are not alive anymore, but you would still find packages from senders that are not around. You will find them that they accumulated in your mailbox. So that's the approach of the Galileo project. That's what we are trying to find. Objects in our vicinity that were sent a long time ago. And this approach was never practiced. And the Galileo project is the first time that there is a serious scientific research project to look for such things. And it's all thanks to my book that came out. And then a few very wealthy people decided to donate money for the project. And now we are pursuing it. And I very much hope we will find something exciting.
Well,
I think we are reaching our time limit, so I can take one more question.
Okay, so I'm going to stay on this topic of technosignatures and ask if you think the radio signature that we received from the direction of Proxima Centauri was a technosignature, or if it was just like space doing space things.
Yeah, so we now know that this was most likely interference from a signal on Earth. And the group that reported that realized that such signals do exist on Earth, and that was probably a mistake. It was just by chance that it pointed in the direction of Proxima Centauri. When the report first came, before they retracted the interpretation, I was very doubtful because Proxima Centauri is the nearest star to us. And, the chance that there will be another civilization, even though we know that it has a habitable planet, the chance of having another civilization in the nearest star is very small, because if there wasn't a civilization in the same phase of our development there, it should be everywhere. And we just developed radio communication over the past centuries. So that's a small fraction of the age of the Milky Way galaxy. It's 1 part in 100 million. So I would think that finding another civilization exactly at the same technological phase is extremely unlikely next to us. And the other problem I had with this report is that if it came from a planet like in the habitable zone of that star, of Proxima Centauri, the planet is moving around the star. And because of that, there should be a drift in the transmission frequency of the radio waves. And that was inconsistent with what they were reporting about. And that led me to suggest that it cannot be real. If it came from a planet that is in the habitable zone, then we would have seen the impact of the motion of the planet on the drift of the frequency from the Doppler effect. That's a very standard effect, and we didn't see it. But at the end, they concluded that it must have been interference from a terrestrial source. So we are still searching for maybe other signals from other places.
It's very important to ask these questions, because there's a lot of talks about this radio signal for people who like to read periodics and articles and etc. It was a really big thing back then. So that's why I asked, and it was on topic. So I just took the opportunity.
But in every report, whenever you hear something, it's important to think about it critically and ask, okay, what would be the implications if that were the case? So for me, I immediately thought, okay, what would be the frequency drift if it came from the planet in the habitable zone of Proxima Centauri, Proxima b, for example. And I calculated it immediately, and I wrote an email to the people who were involved in this detection, and I said to them, look, if you're not seeing this drift, then it's not that. And then they, after a few months, they came up with the announcement that they don't think it came from Proxima Centauri. So that was good.
Okay, so I know that we actually reached our time, but I have to ask you one off-topic question. Actually, it's not off-topic, it's about science still, it's about space and etc. But we have another question from chat, and I think it's a small question. So let me just quickly translate it here. But do you think that is any advantages or disadvantages that the planet Earth have because of having a satellite like the moon? So comparing to other planets, I'm going to make a contextual interpretation here of this question, but like Proxima Centauri planets, we don't know if they have moons or things like this. But if we were to move there in the future, is there any implications on the difference? Because here in Earth we have the moon to dictate tides and etc. And there we don't know.
The moon has an important role in the sense of maintaining the stability of the direction of the spin of the Earth. So the seasons that we have depend on the direction of the spin, and the spin of the Earth would have moved around very quickly if there was no moon to stabilize it. And the existence of the moon is just because early on in the history of the Earth, there was a big impact. Some big object collided with the Earth and released a small piece of the Earth into what we now call the moon. And initially, by the way, I don't know if you know that, but the duration of a day was just 8 hours or so. The Earth was really spinning really fast, and then as the moon moved away, and the spin of the Earth slowed down because the moon was taking with it part of the spin of the Earth into its orbit around the Earth, and so the moon slowed down over time the spin of the Earth, and the duration of a day is now 24 hours. It used to be much shorter at the beginning. And the moon keeps going away from us. Right now it has roughly, it occupies the same angle as the sun. That's why we get eclipse when the moon happens to be in front of the sun. We get a total eclipse. It blocks the sun. But the moon is slowly drifting out. And in some time, hundreds of millions of years, it will become smaller than the size of the sun. There will never be an eclipse. Just keep that in mind, that the eclipse is a very special coincidence right now that can happen because the moon has the size of the sun in the sky. But at any event, you know, if you were to take away if there was no collision with the Earth early on, there was no moon, the question is whether life as we know it would exist. It's quite possible that you would still get life, but it would be different than the life that we have. So one way to find out is go to places in the solar system that have potentially life, like, as I mentioned, Titan is one example. Mars does not have right now, but maybe had early on because it was very similar to the Earth. So we can look for signs of past life, microbes on Mars. But right now we can look for life under the surface of, for example, Europa, which has ice, but under the ice, we believe there is liquid water. And there is another moon, which is called Enceladus, where there are cracks in the ice on the surface, and the plumes of water vapor are coming out of these cracks. And they tell us that there must be liquid water under the ice. So maybe there are fish swimming in that liquid water, who knows? And so we need to explore those places. Even though they have a frozen surface, we can perhaps look for life under the ice. And if we find life in those places, it would tell us that life can emerge in very different environments very easily. And the second question is whether that life is the same as we find on Earth. That would be really exciting to find out if it's the same or maybe it looks different, the DNA structure and all kinds of properties of life. So there is a lot to discover, and the next generation will hopefully discover. What I hope to discover during my life is whether there are technological objects near us that came from far away. And I hope that in the coming years, we will know.
I don't even have actually many words to express, because I know it was the last question we had you to answer, and our timing is really in the end. So I'm very excited to be here talking with you and making questions. So all this is I'm very grateful to be here, and our crew from the DDU, or our organization that made this meeting happen and this presentation happen. First of all, we would like to thank you for being very fast on your reply on the email we sent you with the invitation. So Flavia, the girl who was talking to you via email, she would like to thank you. So Marina, if she has something to say, she can.
Yeah,
she can
just
tell.
a lot of thank yous.
Well, it was my pleasure, and I can tell you that the biggest attraction for me was that I speak to young people, because I gave up on old people. I don't think they will change their views, but the future is with the young people. So I very much hope that whoever listened will make a difference in the world. So thank you for inviting me.
We hope so. Thank you for your availability, and well, for talking to us. Was really good.
A pleasure.
And yes,
Thank you.
just a lot of thanks.
Okay, bye-bye.
Bye. Thank you very much.